G2 minus G1 over L. But the units are percent per station. So if L is 300 feet long, what number do you put in for L?
300.
If L,
3.
if the horizontal length of the vertical curve is
Oh,
300 feet, what number do you stick in here in the denominator?
3.
3, because look, the unit says station.
Oh.
So if it's 300 feet, it was because you were laughing. 300 feet, but we have to put in a 3. Also, if G2 minus G1, if the units are percent and G2 is 2%, do you put in 0.02 or do you put in 2?
2.
2. So this is different. Maybe you could think of that vertex first and say, okay, we can't think like a mathematician, we have to think like a surveyor. So V is not the high or low point, it's something else. So that triggers in your brain when we learn about vertical curves, we have to not think like a mathematician. And a mathematician, and an engineer, would change percentages to 0.0 something, right?
Yeah.
And we don't, because surveyors don't like doing that, they like to keep it as percent. When we talk about how many feet something is, we talk about how many feet something is, but a surveyor talks about how many stations it is. So remember to plug in the percent, don't convert it to a regular number, and put in stations and not feet. Yeah,
So is that entire thing the G2 minus G1 over L, that entire thing's in the units of percent over?
that's correct.
station?
Okay. So, let's look at this example. G1 positive or negative?
Positive.
G2 positive or negative?
Negative.
What's R gonna be?
R is going to be
2 minus G1, negative minus.
A negative
Negative.
minus a positive, so it's gonna be a negative. So R is negative when we have a curve like this. If we have a curve like this, R is gonna be positive. Okay? Beginning of vertical curve, we already know this. Okay, now. Oh, remember what's the equation for a parabola?
I don't know.
Remember?
Like,
Y equals, oh, darn it, there's no pens here.
X to the something.
X squared, or yeah, I guess X to a third.
Anything that's an even power.
power Yeah. plus
Right,
What?
so modulus 2. No, modulus 0.
Y is equal to x squared plus bx plus c. That's an equation of a parabola,
Okay.
okay? That's the equation of a parabola. So let's take a look at this equation.
I don't know.
What is y?
It's like your C. Oh, never mind.
What is the y? The elevation. The elevation of any point, so let's see, do I have stuff up here? Yes. Okay, so y is the elevation at any point. The elevation at any point is equal to the elevation of the BBC plus G1, and how do we write G1?
Percent.
percent
In percent times x. What does x represent?
number.
The horizontal distance to any point represented in stations. Plus r over 2, what's r, what's the units of r over 2? Percent per station, times x, the horizontal distance to n, horizontal distance to point n, and stations, squared. So if we look at that equation, ax squared, what's a? R over 2. What's b? G1. And what's c? The elevation of the BBC. So that means if we know the elevation of the BBC, we could find the elevation of any point. What does this distance represent?
X?
X. What's the end of the vertical curve? What's this represent?
L.
L. What's R equal to? G2 minus G1 over L. This is in percent and this is in stations. So if I know, what's this? What's the slope of this? G1. What's the slope here? So if I know G1, I know G2, and I know L, I can calculate R. I put R over 2. I know G1. How do I get X? X is the horizontal distance to the point in question. I can find the elevation of any point. Got it? And the elevation at any point is this distance to the datum. Good? Okay, let's pull this down. Good? X we know is the horizontal distance from the BBC and stations to any point. G1 we know. What's the difference between this equation and that?
The two,
Nothing.
It's the
nothing,
difference
it's the same thing.
The same thing, but what did I do?
R
Oh, you
is.
put-
I put what R is. R is G2 minus G1 over 2. So notice I put a circle, a number 2 around that, and put a box around that equation. That's equation number 2 that we need to know, and here's equation number 1 we need to know. So far, we only need 2 equations. Okay, now what's the difference? Here's equation 3. What does equation 3 mean?
You just
Tell me what that equation means.
You just put in L.
I put in L. L got what got replaced?
X.
I put L in for X, and then what's the elevation that I'm calculating?
The endpoint?
The end point, UBC. So I put in L, because L is the horizontal distance to the EBC. So do we need this equation? Not really. Right, that's all I did is put L in for X, and the elevation is the elevation of the EBC. So I probably wouldn't even box that in now. Here, Allison, what you were mentioning, equal tangent curves. It means that the station, the BBC, is equal to the station of the VPI minus L over 2. So what does that mean? It means that if I have a vertical curve,
The slope of the tangent lines are equal?
no, actually no, they don't have to be, because look, here's one that's not equal, right? That's all, and this is the BBC, and this is the EBC. That's all it's saying.
I bet it's the same.
The level of the intersection.
It's
This
saying those two
is
distances
L over
are the
2,
same.
and this is L over 2.
Horizontal.
So this one should go a little further to really be an equal tangent. The slopes are not the same, it's just the horizontal distances are the same. So these are called equal tangent vertical curves, and those are the only ones we're dealing with. Seth, would you open the door? Oh, it's easier.
Really?
Just on time.
That is impressive.
What?
Hey, Z! All right. Okay, so equal tangent curves only. We're doing vertical curves now, Z.
Yeah, I saw the story.
Oh. Okay, so now, how do we find the high or low point on a parabola?
Magic.
Take the derivative, set equals 0.
Why?
Because that's where the rate of change, it doesn't change anymore there.
The slope
The
is
slope is
The
zero.
slope is 0, yeah.
So the high or low point
Thank you.
has a slope of 0, right? Here it has a slope, here it has a slope, here it has no slope. The slope is 0. M is not surveying the term, that's the math term, right? The slope is equal to 0. So if I have an equation, if I get the derivative of it, okay, let's see. The derivative of y dx equals 2ax plus b. right?
Yeah.
Okay, set it equal to 0. X turns out to be negative b over 2a. So if I say when the slope is 0, I could solve for x. What does that give me? It gives me the distance from the BBC, the x, to the high or low point. Should we put high point, low point? Let's do that. That's an important equation because I don't want to do the derivative on the test. I just want to know that the horizontal distance to the high or low point is negative b over 2a. So what does that mean in terms of surveying? Well, I don't know what a and b are in surveying, but I do know that x turns out to be, if I did the derivative of the parabola equation we had, it's negative g1 over r. Okay, so no matter what vertical curve I have, as long as I know g1, g2, and l, I could solve for what the high or low point is. How do I know if it's a high or low point?
You can take the test points on either side of that
Easier.
coordinate.
When I calculate r, it's a high point, r is negative. If it's a low point, r is positive, right? So x represents the horizontal distance from BBC to the high or low point. So you might want to just say, it might be best to write high point, low point. Okay, how do we know if it's a high or low point? We already know that. Okay, we're done with the instruction. I mean, that's it. Now let's do a problem.